Sequences. So the first part of sequences is being able to spot a pattern and to find the next terms in the sequence given that pattern. Now the first four of these questions are ones that you really need to be able to spot. As soon as you see them, you should be able to recognize them. So do we recognize number 1, 2, 3, 5, 7, 11, 13, 17, 19? Well, you can see that the differences are kind of changing, and you should spot that these numbers are actually prime numbers. So a prime number obviously is a number with just two factors. That's why 1 is not a prime number, because it only has one factor. You can only divide it by 1. Whereas 2 has two factors, 1 and 2. The number 4, for example, has three factors, 1, 2 and 4, so it's not a prime number. So basically anything that the only factors are basically 1 and itself. You can't have anything else. So obviously you should recognize these numbers. Now what's the next one? Now obviously the only even prime number is 2. So they all have to be, after that, they all have to be odd numbers. So 21, no, because it's 7 times 3. 23, does anything go into 23? No, that's the next one. 23 is the next prime number, because you can't divide 23 by any number apart from 1 and 23. Next number, 25, obviously not, because 5 times 5. And 27, no, 9 times 3. 29, yeah, 29. Okay, so you should be able to spot the prime numbers straight away. What about these numbers? Hopefully you can spot these. This is obviously 1 squared. This is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So it's just the square numbers. So obviously the next one is going to be 7 squared, which is 49. And then 8 squared, 64. So you really have to be able to spot this sequence of numbers. What about this one, question 3? What do we think? Yep, it's actually the cube numbers. Okay, so 1 cubed, 2 cubed, 2 times 2 times 2 is 8, yeah, 3 cubed, 4 cubed. So the next number will be 5 cubed, 5 times 5 times 5, which is 125. And the next one, 6 cubed, which is 216. Okay, so these were the square ones. And these are the cube numbers. Again, you have to just be able to spot these straight away. Okay, question 4. This is actually kind of unusual, but it's a common one. Hopefully you can see how it's made. Well, it's a famous one. It's called Fibonacci. Not sure of the spelling of this actually. Fibonacci, I think actually Fibonacci. You might want to look up that spelling. Okay, we'll leave it like that for now. It might be 1B actually. Fibonacci. Okay, never mind. So you start off with 2 numbers. The most famous one is starting off with 2 ones, and then the next number is these 2 added together. So 1 and 1 makes 2. And what you do is you add the 2 previous ones to get the next number. So 2 plus 1 gives you the 3. 3 plus the 2 gives you the 5. 5 plus 3 gives you 8. 8 plus 5 gives you 13. 13 plus 8 gives you 21. So the next one will be 21 plus the 13, which is 34. And the next one will be 34 plus 21, which is 55. Okay, so these are the Fibonacci numbers. And like I said, you don't have to start with 1, 1. You could be other numbers. So you kind of have to spot whether it's going up in that type of sequence where the next one is adding the 2 before or something like that. Okay, so now we're into kind of more normal ones. Hopefully you can spot number 5. Yep, you can see the sequence is just going up by 3 each time. So it's quite useful sometimes in a sequence to find the difference between the numbers. So here it's 3. All the differences are 3 between the numbers. So obviously the next number will be 20, and then the next number after that will be 23. What about number 6? Well, again, the sequence is going down by 5 this time, isn't it? Each time it's going, the difference is -5 each time. So you can see that the next number obviously is going to be 10 and then 5. Now, with these types of sequences, we're going to look at these in more detail later. These are called arithmetic. Or they can be called linear sequences, because we'll see later that the pattern is just a linear pattern with just an n in it. So it's like the equation of a straight line, basically. These numbers come from that. So they should be easy to spot. Just look at the differences, and if all the differences are the same, you know it's a linear or arithmetic. Okay, what about question 7? Well, you can see all the differences are actually changing, but what we notice here is that the next number this time it's being multiplied by 2 each time. Okay, so look out for the ones where it's growing, and it's growing by multiplying by the same number to get the next term. So again, to get the next one after that, obviously we just have to multiply by 2, 96, and then we're going to times that one by 2 again. What's that? That is 192, isn't it? Yeah. Okay. So that's the next 2 terms. So multiplication each time. This one, well, it's quite similar, but this time we are not multiplying, we are dividing. Okay, and we're dividing by 3. But actually it still is multiplication, because if we're dividing by 3, it's timesing by 1/3, isn't it? Actually, it's timesing by a third. A third of 162 is 54. So either think of it as a division, or for later when we do the formula, it's better to think of it like a multiplication, actually. But it doesn't matter. So you can see we're dividing by 3 each time. So the next number after this will be 6 divided by 3, which is 2, and then 2 divided by 3, so 2/3 basically. So these types of sequences, they are called geometric. Geometric. Okay, so a geometric sequence is when you're basically multiplying by a number to get to to get to the next term, and if it's being multiplied by a fraction, obviously it's like dividing basically. Okay, so you should be able to spot those reasonably easily. What about this one? It's kind of a bit different. Well, okay, we can have a look. You can see that the differences are not the same. We can see it can't be a geometric, because if you times this by, you'd have to times this from here to here, you'd have to times by 3. And if you times by 3, that's not going to work, is it? Because it has to be the same number each time. So that doesn't work. So in this case, probably a good idea is to work out the differences between the numbers. Here you can see the difference is 8. 4 plus 8 is 12. The difference between the next 2 is 12. Difference between the next ones is 16. And from 40 to 60 is 20. So we can actually see in this case that there is a pattern with the differences between the numbers. So you can see it's going 8, 12, 16, 20. So the differences are going up by 4 each time, aren't they? Yeah. So the next one will be 24, and after that the difference would be 28. Yeah. So we're following a pattern in the differences. So if the difference to the next one is 24 and we're at 60, that's going to be 84. And then we need to add on 28 to get to the next difference. So that's going to be 112, isn't it? Yeah. Okay, so look out for the pattern in the differences of the numbers. Now, that doesn't really have a name for that one, but later on we'll see that we're able to work out the formula for these ones, because it involves a quadratic actually, which I'll show you later. What about this one? Now again, it doesn't seem to be timesing, does it? They're getting bigger, but it's not a constant number, because 12 to 36 is times by 3. But obviously 2 times 3 is not 12, so that's not helping. Okay, so let's work out the differences between the numbers to see if that would help us. So this difference is 10. This is 24. This is, what's that? 44. And this is 70, isn't it? Now again, that doesn't seem to be helping either. So we can actually go down another level. Okay. So we can find the differences of the differences. Okay. You won't need to go any further than that, actually. So if you keep going with them and it doesn't work out, then give up on it. Must be something else. But let's have a look at this one, because from 10 to 24, that's 14, isn't it? 24 to 44, that is 20. And 44 to 70, that is 26. So can we see that there is a kind of a pattern here in the differences, of the differences, because the gap here is 6, isn't it? And here it's 6. So that suggests that the next one should be 6 as well. So in other words, the differences, the second differences, are going up by 6 each time. So the next second difference will have to be 32. The one after that would have to be 38, and the one after that, actually I don't know if we need it, but let's keep going. Yeah, maybe we do. The one after that, add 6, that's 44, isn't it? Okay, these are the second differences. So now the first difference is 70 and 32, that's 102. Okay, and 102 and 38, that will be 140. Okay, so now I know that the difference, it has to be 102. So can we see that the next number is actually going to be 252, and then the difference is 140 to the next one, so that's going to be 392. Okay, so in some cases you're going to have to, I'm not sure if there's any questions like this in the book at the moment, but sometimes you will have to go down to the kind of the second difference to find the pattern. And what we will see later is that number 9 will be a quadratic and in the formula, and number 10 will be a cubic. There'll be an n cubed in the formula. You'll see later. I just wanted to mention one more one which I forgot to do, which is this sequence: 1, 3, 6, 10, 15. Okay, because this has a special name. These are the triangular numbers, and we will look at these in a bit more detail later. But again, it's one of these ones where if you look at the difference here is 2, 3, 4, 5, and then it would be 6. So the next number would be 21, and then the difference would be 7, so 28. Now, why are they called the triangular numbers? Well, it's because the first one you kind of have to just have one dot, but in the second triangular number you have to imagine triangles where you have like this 3 dots, and then the next triangular numbers you have to imagine we have another row on the bottom made like this. So you have 3 plus 2 plus 1, which is 6, and so on. So you end up with that's why the name comes from, the triangular numbers. So the next one would be 10, and so on. So in actual fact, you can think of this first number as just 1, but the next number is like 1 plus 2. The next number is 1 plus 2 plus 3, and so on. So they are the triangular numbers. So the first task is to do an exercise from the book where you have to spot the pattern in the numbers, and in most cases you have to find the next 2 or 3 terms.